All right, here we have a question where we're asked to take a string and figure out how many substrings are anagrams of other substrings and to count the total number of anagrams. And of course, this says given number of pairs of substrings. That's technically not correct. What they actually are referring to are connected substrings. So, for example, here, I'm trying to see if I can come up with a good example. I can't really from these examples, but basically for S being equal to mom, the substrings are, of course, you have M, O, and M. You've got MO, you've got OM, and you've got MOM. But if you're actually talking about all the possible substrings, then MM is a substring. However, that's not included in this problem. For this problem, the substrings have to be connected. So the only substrings of length 2 are MO and OM. Oh, well, here's a good example of this. So in ABBA, if you're talking about all substrings, you could make a substring of letters 1, 2, and 4. And you could make a substring of letters 1, 3, and 4. And both of these substrings contain the letter A twice and the letter B once. And so these are anagrams of each other. However, this is not included in the list of anagrammatic pairs because these substrings are not connected. So we basically just want to go through and count them all. So let's go ahead and write this function. And so basically when I went through this, here, the first thing that we want to do is we want to count the occurrences of each unique connected substring. And of course, so basically what we're going to do is we're going to make a dictionary of all the substrings. And for each substring, we're going to count its occurrences. But the reason that we're able to do this is because of, let's see here, I like to refer to all of the comments that I see in the comments section that end up being really helpful for me. So a comment by someone gave me the idea to use sorting. So basically, I was able to get most of the way there, and I got a code that worked, but it timed out. Because basically what I did was I wrote a separate function that, given two strings, this function would determine if these strings are anagrams of each other. And basically it was sort of inefficient because it's literally just looking through the letters of the anagram and making sure that it lines up. I tried to use dictionaries in this, but it still wasn't efficient enough. And so this sort of goes to, you really want to get Python to do as much of the work for you as possible. And so part of this is that Python is able to sort things for you. So this function that I was looking at to take two strings and see if one is an anagram of the other is really not necessary, because what you can do is you could just take these two strings and sort them. And if the sorted strings are equal, then they are anagrams of each other. And that's also necessary for defining this dictionary, because this dictionary counts the number of unique connected substrings, and I guess you could say up to ordering. So these substrings are unique up to reordering. So ABB and BAB would both be stored in this dictionary under ABB because that's sorted. Okay, so let's go ahead and we're going to do sort of this. We've used this sort of these couple lines of code to define dictionaries in a couple of these questions in this past section. So I think this is one of the big things that we want to take away, is this sort of the way that we define dictionaries. But anyway, so for I So what we want to do is we want to get all of the possible connected substrings. So basically what we're going to do is we're going to, we want to to get all the connected substrings, we have to say, okay, choose all the starting points for the substrings and all the ending points for the substrings within the string S. So for the starting points, you could start at any letter in S, and so I is going to be the starting point. It's going to be index where you start the string, and then where you end the string, it could be, you can go as many letters as you want until you hit the end of the string, and so that's what J is looping through. So what we're going to do is we're going to, the substring that we're going to look at is going to be, we want to take, let's see here, so I through J plus 1. This is going to be the substring in question. So we start at index I and we go through index J plus 1. And of course we're adding the J plus 1 here because when we start J at I, yeah, it's just, you gotta work with the indexing and the off by ones and everything, but this is how you get all the different substrings. So this is the substring that we're looking at, and so looping through all the I's and J's in these for loops is going to give us all the different connected substrings. And so this is going to be the substring in question, but to store it in the dictionary, we want to order it. And so this is another thing that I didn't know before I did this problem, so that's why I sort of needed to look at the discussion and see this comment in order to not only think to use sorting, but to sort of see what tools Python gives you to sort things. So we want to join sorted S blah blah blah. Okay, so basically what's happening here is Python has this this function called sorted where you can input something, for example here a string, and what it will give you is it will give you an array of all of the letters in the string sorted. However, that's not exactly what we want because we don't want an array, we just want this, we want to get a string which contains all the same letters but which is itself sorted. So to convert this array of sorted letters into just a single string, basically what we do is we take an empty string and then we join all of these individual letters to it. And what happens when we do this is that it gives us a string at the end. So this is something to keep in mind if you ever want to be able to do something like this in your code. This is a good way to just sort of, given a string, reorder or sort the letters in the string but return a string rather than an array of letters. Okay, so this is good to keep in mind. And then we do this thing that we've done before, which is we take our dictionary and we set the default value of substring to be 0. So we make sure that that the substring is in the dictionary if it's not already there, and then we increase its value by 1. So yeah, these two lines are the things that come up a lot, and these are really useful for defining dictionaries. So I think that's one of the big takeaways for this problem section is really know this and sort of memorize this so that you're able to use these lines of code to define dictionaries in whatever questions you might come across. All right, so now we have a dictionary that goes through all of the different connected substrings and counts the number of times that they appear sorted. And the sorting makes sure that you account for the anagrams. And so that's how we get our dictionary, and then we can just use this dictionary to count the number of occurrences of each substring. So basically what would happen in this dictionary, for example, if we look at the ABBA example, is, let's see here, so AB and BA would both be stored in the dictionary under AB, and its count would be 2. So that's sort of how the dictionary works. It takes all the connected substrings, orders them, and counts the number of times that they occur. So now what we got to figure out is, now that we know the number of times that each substring occurs, we want to count the number of anagrams. And so for this, we need to think a little bit. So let's see, how do I, what? Okay. Is it Alt Tab? Yeah, there we go. Okay, so let's say that we've got, let's take our, the number of occurrences, and then the number of pairs. Okay, so if we have a string which occurs only one time, then you can't form any pairs. And if you've got a string that occurs 2 times, then you've got your single pair. If you have 3 occurrences of this string, then you imagine you have 3 dots and you think how many pairs you can form. You can form a pair from these two, or these two. Or another way is, if you start with all the ones that connect with the first dot, you have 1, 2, and 1, 3. And then if you think of all the ones that connect with the second dot, you have 2, 3. And so you get 3 distinct pairs. Similarly with 4 occurrences, 1, 2, 3, 4. Okay, so we've got 1, 2, 3. Then we've got 1, 2. And then we've got the final one here. So we've got 6 here. And then if you go with 5 and do the same thing, you get 10. So if you look at this as a mathematician, you might recognize this. These are called triangular numbers. And the way that you can form this is 1, so 3 is 1 plus 2, 6 is 1 plus 2 plus 3, and 10 is 1 plus 2 plus 3 plus 4. And you can sort of see why this works if we look at number of occurrences 3 and number of occurrences 4. So if we just sort of focus on this section here of the dots from occurrences 4, these section here, this gives you just the number of, you can count the number of pairs that you form within these 3 dots by just looking at the number of occurrences that you get among 3 dots, because this that I have circled here is equal to this figure that we have for 3 occurrences. And so we get the original 3 that we have from the previous occurrences, and then when we add this 4th dot here, this 4th dot connects to all of the 3 other dots that were already there. And so we add on this 3. That's where the 3 comes from. And then, of course, the 1 and the 2 come from the previous number of occurrences. And the same thing happens between 4 and 5. The 1 and the 2 and the 3 come down because you get all the pairs that you had for 4 occurrences. And then for that 5th occurrence, it can connect to any of the 4 remaining occurrences, which is where this 4 comes from. And so that's why this formula sort of works for that's why this pattern occurs. So basically what we can see is that if you want to get the number of pairs that you get for n occurrences, what you can do is so n, here, I'm going to readjust my screen here so that I can sort of write this a little better. So n occurrences yields 1 plus 2 plus etc. And we go all the way up to, let's see here, for 4 occurrences, the last number we ended up at was 3. So we get up to 1 plus 2 plus all the way up to n minus 1. pairs. And so this is equal to the sum from k equals 1 to n minus 1 of k. And so this number is the n minus 1 triangular number. And there is a formula for this. And this is something, if maybe you've seen this, but you don't have to have seen this, especially not for this problem. But the formula, this sum is equal to k, let's see here, so it's going to be n minus 1 times n over 2. All right, so we now have a formula for, given the number of occurrences of a string, or given the number of occurrences of a substring, how many pairs of anagrams do we get? And so we basically go ahead and we loop through the dictionary, and for each entry in the dictionary, we're going to take how many times this substring occurs, which is what the dictionary tells us and what the dictionary is storing, and we're going to compute the number of additional pairs that we get using this formula. So let's see here. So count the number of combinations, or rather the number of pairs using triangular numbers. All right, so we're going to start with our count is going to be 0. And then for each string in our dictionary, we're going to take count and we're going to add on. Now, let's see, what I wrote here was integer. Okay, so I use the formula. So we take the entry, the number of occurrences of string minus 1 times the value divided by 2. And this is literally just the formula that we had before. I'm not putting the numerator in parentheses because it will just read left to right, and so this is fine. And I used integer because dividing by 2 will automatically switch it to a decimal. But first of all, triangular numbers are always going to be whole numbers, so we're never going to get a 0.5. You can also see that because the numerator is always an odd times an even, which is going to be an even, and so dividing by 2 will give you a whole number. But just to get rid of, so it's always going to be an integer anyway, and so we can just convert it to the integer type. So we're going to do this, and then we're going to return the count. So this is how I went about doing it. However, if you're in like an interview scenario, you're not gonna, or there's no reason to know the formula for triangular numbers. So what I did, even the first time I wrote this, was I just did, let's see here, so we can just take the sum of I for I in range D string. And now there is something here. So D string tells you the number of occurrences, and so if we set D string to be n, so if we have n occurrences of a particular string, what we're looking for is we're looking for the n minus 1 triangular number. However, range of n will take the number 0 through n minus 1. So that's already accounted for. The sort of off by 1 errors cancel each other out in this case. And so that's why we go up to D string instead of D string minus 1. But yeah, so that's how you could go about doing this. However, this formula, if you do know it, it does work slightly faster, but it's not going to make a difference between the code running and not running. But yeah, so let's go ahead and run this. And it seems to work. So we can go ahead and submit the code, and it works. So yeah, okay, I don't want that. All right, so Yeah, this is, I guess the main things to keep in mind here is that, first of all, you need, it's not super well explained in the description of the problem, but you can sort of gather in their discussion of the examples that what you're looking for is unique connected substrings and counting the occurrences of each unique connected substring up to reordering. And of course, by that I mean that two substrings which have the same letters in different orders are considered the same. And so basically what we want to do is we want to create a dictionary to store all the values and then count the number of occurrences. And again, so what you need to know is you need to know, given the number of occurrences of a substring, how to count the number of pairs. And you can use this formula for triangular numbers, or you can just do this sum formula. But in either case, I think it makes sense to sort of like do what I did, where you actually write out on a separate piece of paper or something what the pattern actually looks like. And then once you start to write it out, you'll immediately see like, oh, this is how I can come up with these numbers. Or even if it's not immediate, it will give you an idea of how to set it up. And then again, this knowing how to set up dictionaries is really important, of course, in the dictionaries section of the HackerRank challenges, but also just in general coding. Being able to set up dictionaries for exercises like this is really important. And then also knowing how to create sorted strings, which is something that I didn't know going into this exercise, and something that I needed to learn in order to solve it. And also just recognizing the fact that you need to really use sorted, to recognize that sorting the strings is a really useful tool for this, because the first time that I tried solving this, I didn't use sortings, and I had a manual function that determined if two strings were anagrams of each other, and it was not efficient. So yeah, this is how you go about writing. So those are sort of the key ideas that you need to keep in mind for this exercise and for exercises like this. And once you have those in mind, you can create the code, and this is what you end up with, and it works.